Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. In today's video, we are going to discuss the topic arcs and chords. Let's see what is the meaning and explanation for arcs and chords. Then we can see the theorems on arcs and chords. And let's also see the application of the theorems in few examples. Here is a circle with center O. I have drawn two chords AB and CD. A chord is just a line segment with endpoints on the circle. We want to know when two chords in a circle are congruent. This conjecture will tell us that the central angles determined by the congruent chords are equal in measure, which implies that the intercepted angles are also congruent. This conjecture also tells us that the distances from the center of the circle to the two congruent chords are equal. You should also be familiar with the precise statement of the conjecture. Let me state what are they. There are three statements. Point 1. If two chords of a circle are congruent, then they determine the central angles which are equal in measure. Next one is, if two chords of a circle are congruent, then their intercepted arcs are also congruent. Third one is, two congruent chords in a circle are equal in distance from the center. If you measure the distance from the center point, the distance will be same. If it is same, only then you can say that the two chords are congruent. You have to be familiar with these three statements. Now let me show you a figure where the measure of the two arcs on the same circle will be equal when two chords are drawn. There is also a theorem using this concept. In this figure, a circle O has radius OI, OA, OB, OC and OD. These are the four radii. If chords AB and CD are of the equal length, in case if this is true, it can be shown that the triangle AOB is congruent to triangle DOC. So this would make measure of the angle 1 will be equal to measure of angle 2. Let me write that on the board. In turn, this would make measure of angle AB is equal to measure of the arc CD. Arc AB would be equal to arc CD. This is one important theorem relating the chord and arc. I have highlighted the arcs in pink and green. So measure of arc AB will be equal to measure of the arc CD. Hope you are clear with this theorem. Let us move on to the next theorem where I will state and prove the theorem. This one on the board is just the information. This will be applicable in many theorems and problems. Here is the theorem. It states that if in any circle two chords are equal in length, then the measure of the corresponding minor arcs are same. The concept that I have just before explained you, I'll be stating and proving that in theorem format. Before that, let me draw the figure on the board for your better understanding. The same concept. So as shown in the figure, A, B and CD are congruent chords. Therefore, according to the theorem which we stated, you can say that measure of the arc AB is equal to measure of the arc CD. Or you can also say that measure of angle AOB will be equal to measure of angle COD. To prove this, let us join ABCD with O. Consider the triangle AOB and consider the triangle COD. Segment AO is congruent to segment CO. Am I right? And segment OB will be congruent to segment OD. Because radii of a circle are always congruent. I'll also add the reason behind that. While proving any theorem, whenever you are stating any point, you have to add the reason why you are stating that point, so that it will make your proof very clear and it will be very understand. And now let's say that from the figure, segment AB will be congruent to segment CD. Am I right? AB, CD, because these are the two chords and it is given in the theorem itself. So these are the three sides of the triangle. Am I right? Side, 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 side. So by the side, side, side postulate, you can say that the triangle AOB is congruent to triangle COD. Do you agree with me? If the triangles are congruent, then you can easily say that the angle AOB will be congruent to angle COD. Because the corresponding angles of a congruent triangle are also congruent. Hence the arc AB will be congruent to arc CD. Hope you are clear with the statement and proof of the theorem. Okay, now let's see its converse. Conversely, it can also be proved that in the same circle or congruent circles, Congruent arcs have their chords congruent. It is just the reverse of this theorem. In this figure, if the arc LM is congruent to arc PQ, then we can say that the segment LM is congruent to the segment PQ. To prove this, let us join LMPQ to the center O. Consider the triangle LOM and POQ. The segment OL is congruent to segment OP. Same way, segment MO will be congruent to segment QO because all these are radii. Therefore, you can take that the given angle LOM is congruent to angle POQ. Using this, you have to prove that the segment LM is congruent to segment PQ. Okay, let us take the given information here. Two of the sides are congruent and one of the angle is congruent. So you can use side angle side postulate here. So by SAS postulate, you can tell that the triangle LOM is congruent to triangle POQ. Do you agree with me? Okay. Since the corresponding sides of a congruent triangles are congruent, you can say that the segment LM is congruent to segment PQ. Hence we proved the converse of the previous theorem. Hope you are clear with this converse theorem. Okay. Next we are going to discuss a theorem where you will be seeing the perpendicular from the center of the circle to a chord. You have to prove that the chord, the center of the circle to the chord of a circle bisects the chord into two equal halves. Okay, this is one important theorem. Here is the statement of the theorem. The perpendicular from the center of a circle to a chord of a circle bisects the chord. Okay, let me draw a figure for this one. In this figure, XY is the chord of the circle with center O. Segment OP is the perpendicular from the center of the chord. Let me name this as P. OP should be a perpendicular from the center of the chord. According to the theorem stated, you have to say that segment XP is equal to segment YP. So let us prove this. First, join OX and OY. Consider the triangle OXP and OXY. Okay. Both are right triangles. Hypotenuse segment OX is congruent to hypotenuse segment OY. OXP and OYP both are right triangles. Okay, hypotenuse segment OX is congruent to hypotenuse segment OY because both are radii of the circle. These are two radius. Am I right? Same way you can say that the segment OP is congruent to segment OP. That is by reflexive property. This is one side of the triangle, this one XOP, and one side of the triangle OYP. When hypotenuse and one of the other side of a triangle are congruent, you can say that the two triangles are also congruent. So therefore, triangle OXP is congruent to triangle OYP. Therefore, the segment XP is congruent to segment YP because corresponding sides of congruent triangles are congruent. And you can say that P is the midpoint of the segment XY. Hence, segment OP, which is the perpendicular from the center to the chord segment XY, bisects the chord segment XY into two equal halves. Now consider two chords of equal length in the same circle. The distance from the center of the circle will also be same. Hope you are clear with this theorem. Okay. We have many theorems, but it will be a little bit vague if I explain you theorems one by one. So let me take one example and explain you, and then we'll go towards the theorem after the example. Here is an example. AB and CD are two chords in a circle with center O. First segment AB will be equal to one of the segments CD, which is equal to 3.5 centimeter. Measure of the angle COD is 95 degrees. These are the given information. We are supposed to find the measure of the arc AB. So 95 degree is given. Measure of the arc AB equal to measure of angle AOB. Am I right? From the very first theorem. Since the triangle AOB is congruent to triangle COD by SSS theorem. Hope you remember the theorem. You can easily say that measure of the arc AB will be equal to measure of the arc CD. Am I right? So if measure of arc AB is equal to measure of angle AOB, measure of arc CD will be obviously equal to measure of angle COD. From the theorem, we proved that these two angles are equal, and we know that COD is 95 degrees, which is given in the question itself. So, measure of the arc. That's it for this example. Hope you're clear with this example. We have applied theorem 1 in this problem. Okay. Here is the next example. PQ is a chord and O is the center. Segment OR is a radius that intersects PQ at right angle. Okay. If PT is equal to 1.5 centimeter and measure of the arc PQ will be equal to 80 degrees. Okay, so let us take down all the given information and find the PQ and measure of the arc PR. These are the given information. So we are supposed to find the line segment PQ and measure of the angle PR. I mean the arc PR. The length of the line segment PT is 1.5, and we know that if a perpendicular bisector goes, we can say that the chord will be equally divided. That means it bisects. So PT and TQ will be equal. So the line segment PQ will be PT plus TQ, that is 1.5 plus 1.5, which is equal to 3. I am using the theorem that we just discussed. When the chord is bisected into two equal halves. So 1.5 plus 1.5, which is equal to 3. So we found what is segment PQ. Now it remains us to find what is the arc, measure of the arc PR. Let us use the given information itself. Measure of the arc PQ is equal to 80 degrees. So if this is 80 and half of this is 40, am I right? Because if the segment OT is perpendicular to PQ and therefore it bisects PQ at T, it means the line segment PQ will be equal to 2 times the PT. Therefore, the segment OR bisects arc PQ. Therefore, measure of the arc PR will be half the times of measure of the arc PQ, where PQ is 80. That is the given information. Half of 80 is just 40. Hope you understand the application of the previous theorem in this example. Okay, we have a few more theorems and its application. We can see that in our next session. Hope you are clear with all the concepts that we discussed in today's video. In case if you have any query, you can let me know. See you in the next video. Have a great time ahead.